Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to perform translation movements on geometric figures, reflection movements on geometric figures, and rotation movements on geometric figures. How are we learning it? Through the Rigid Transformations Part 2 notes, the Rigid Transformations Part 2 assignment, and the So What's Your Point assignment. When can we use this information? To determine whether furniture will fit in areas of your house if you move them, to understand why mirrors invert the appearance of things by switching the left and the right, and to set the time on a non-digital clock. How do you know you learned it? By getting a score of 4 on the Rigid Transformations Part 2 assignment, as well as a 4 on the So What's Your Point assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Rigid Transformations Part 2 notes, and I'll give you time to complete the Rigid Transformations Part 2 assignment on IXL. Now, if you've already completed the assignment and gotten a SMART score of 80, you'll move on to the So What's Your Point assignment on Desmos. At the end of class, we'll go back over our learning goals and success criteria while you fill out before you go. Your only homework for tonight is to continue working on the Transformation Study Guide and any incomplete assignments that you may have. Let's take a look now at the Rigid Transformations Part 2 notes. The notes begin with the learning goals and success criteria. Now here's a little video. We have translation. Notice every person in here is the same. They don't change shape or size, but they are sliding around. They're sliding side to side. They're moving front to back. Those are translations. So it is a slide of a figure or a point. So for instance, we have a triangle here. And if we slid it to the right and up, it would end up being this triangle here. So it's just a slide movement. So introduction to translations, here's our triangle. If we were to slide it, it could move and look like that. Or we could slide it down. Or we could slide it to the left. So all of these are translation movements. Translations are slide movements, and it does not change size, shape, or position. Notice it doesn't change direction. It doesn't flip and turn. It doesn't flip over. It doesn't rotate at all. It's exactly the same. It stays, the top stays the top, the bottom stays the bottom, the left side stays the left side, and the right side stays the right side. It just slides around. So there's two ways that translations can be written. We could write it as a direction side to side and up and down. So we could say we're going to move to the right 6 units and then down 4 units. Or we could write it this way, T, and then these little carets here, and then XY. X represents the change in the X, so the side-to-side movement, and the Y represents the Y movement, so the up and down movement. So let's look at an example. So we want to find T of 3, -2. So what we're going to do is take each of the points and move them to the right 3 and down 2, because we're going to have a change of +3 on the x-axis, so everything's going to slide to the right. And then -2 on the y, so it's going to go down 2. So I take each point and slide it to the right 3 and down 2. So let's start with this one. So we slide to the right, 1, 2, 3. And then down 2, 1, 2. And plot that point. Then we do it for this one, to the right 3, 1, 2, 3. Down 1, 2. And plot that one. Then this one, to the right, 1, 2, 3, and down 1, 2, right there. And notice when I create my triangle, I should end up with 2 triangles that are exactly the same, just slid over and down. Let's look at another example. It says, take the shape below and move it up 4 units and to the left 3. So again, take each of the points, move them to the left 3 and up 4. So I move this point to the left 3, 1, 2, 3. And then up 4, 1, 2, 3, 4. So I should have a point there. Then I have this one to the left, 1, 2, 3, up 1, 2, 3, 4. There we go. Then again with this one to the left, 1, 2, 3, up 1, 2, 3, 4 right there. Connect my dots, and now I have 2 triangles that are exactly the same again. Now here's a little video of Simbo looking at his reflection in the water. So that's what a reflection is. Reflections occur when we flip a figure over a point or line. So for instance, we have a triangle here. If we flip it over this line, it's going to flip downward and look like this. So that's a reflection. So introductions to reflections. Reflections over a line, we start with, for instance, a triangle here. If we flip it over, it becomes like this. So if we flip it over that line, it becomes this way. So it can be up and down, or it could be side to side. So it could flip and go over here as well. Notice they do not change size or shape. They do change direction, though. So it will flip over and it will look inverted, but the size of the triangle in this case does not change. Reflections can be written in two ways. So we could write it as a statement. I could say, hey, we're reflecting this over the y-axis. Or it could look like this with the r, and then below that, it's going to say the equation for the line that we're reflecting over. So for instance, we have r y-axis. So that means we're going to reflect it over the y-axis. So first of all, first thing we always do is draw in the line of reflection. So where are we reflecting? Well, the y-axis is right here, so I draw in a little dotted line. This is what we're reflecting over. Then we're going to count the distance to the line of reflection. So we're going to take each point. For instance, this point here. And we count how far away it is from the line of reflection. So it's 1, 2, 3, 4, 5, 6 away. And we're going to copy that distance to the other side. So over here. So we go 1, 2, 3, 4, 5, 6 away and plot our point. Then we do it for each of the other points. So here, this one, 1, 2, 3 away. So we go 1, 2, 3 away on this side. And then the same thing here, 1, 2, 3 away on this side. So 1, 2, 3 away on this side as well. And then we just draw our triangle. And notice we have two triangles that are exactly the same size. Let's look at another example. Now we're reflecting over the x-axis. So here's our x-axis. So we draw it in. Then we count the distance. So here we are 1, 2, 3, 4 away. So we go 1, 2, 3, 4 away and copy that over here. Then we look at this one. This one is 0 away. So it's going to be 0 away on the other side. So we just leave the point there. Then this one is 1, 2, 3, 4, 5, 6 away. So we go 1, 2, 3, 4, 5, 6 away on this side and draw in our triangle. Now what if we reflect over the line x equals -1? So again, draw in your line of reflection. So x equals -1. So when x is -1, it's right here. So it's a vertical line right there. Same thing, copy the distance. So 1, 2, 3, 4, 5 away here. So we go 5 on the other side, which is 1, 2, 3, 4, 5 right there. And then same thing, 1, 2 away on this side. So 1, 2 away on this side. And 1, 2 away on this side. 1, 2 away on the other side. And now we have our drawing. Again, it's reflected. It's just reflected over a different line. Now, what is a rotation? A rotation looks like this. So we have Woody's head here, and it spins around. So rotations are spin movements. So it's a spin of a figure around a point. So we have a triangle here. If we were to spin it, it ends up being this triangle here. Now, introduction to rotations. We have our triangle here. If we were to spin it to the right, it would look like that. If we were to spin it again, it looks like that, and again, right there. So we're just rotating and spinning that triangle. So rotations are spin movements about a point in which the object moves and it doesn't change size or shape. So notice the triangle is exactly the same size, but it does change direction. So rotations are typically only written in one way. It's a statement about a point, and for everything we do, it will always be the origin, and then it's going to give you a degree measure. So how far are we rotating? We're rotating 90 degrees, 180 degrees, etc. And then it will tell you a direction. So rotating 90 degrees. So if I were to take this and rotate it 90 degrees, I'm going to flip it and turn it sideways. So either of these would be a 90-degree rotation. So that creates a need for us to have a direction, right? Because if both of these are a rotation of 90 degrees, then which one's the correct one? Well, we need to tell which way we're rotating. And the way we do that is by talking about it in terms of clockwise and counterclockwise. So if you notice, we have a clock here, and the numbers go in a certain direction. So a clockwise rotation would rotate this way. A counterclockwise rotation would rotate this way. Now, understanding the graph. So if you notice, we have our x and y axes here, and it ends up forming these 4 boxes. Now, every movement, every time we rotate 90 degrees, we're going to move from one box to the next. So, for instance, if we had our triangle here, and I said I want to move 90 degrees clockwise, I'm going to take that triangle and move it in the direction of a clock, and it's going to move down into this box. Now, if I want to go 180 degrees clockwise, well, that means I move 2 boxes, because 180 is just 90 times 2, so we move 1, 2 boxes, and we end up over here. Now, if we want to go 270, now that's 3 boxes, so 1, 2, 3, and we end up over here. So how do we rotate these things? So the first thing we need to do is write out the coordinates. So, for instance, this is 1, 1, this is 5, 1, and this is 3, 5. Those are the coordinates. Then we decide which box we're rotating into. Let's say we're going to rotate into this box here. So that would be a 90-degree clockwise rotation. The rule is, for every 90 degrees that you rotate, you're going to flip your x's and y's. So your x's become your y's, and your y's become your x's. So 3, 5 would become 5, 3. So for every 90, we flip them. So we change this to 5, 3, we change this one to 1, 1, and we change this one to 1, 5. And then we need to match the signs with the box that we're in. So over here, we have positive x's and negative y's. So we're going to change all of our y's to be negative. So 1, negative 1, 1, negative 5, and 5, negative 3. And then we can plot our points and just draw it in. And notice this should be the exact same triangle, just spun around into this box here. So let's look at an example. So we're going to rotate 90 degrees counterclockwise. So again, write out your coordinates. So there's my coordinates, negative 3, 6, negative 6, 4, and negative 3, 0. Then we're going to decide which box we're rotating into. So we're going counterclockwise, so we're spinning this direction. And we're going 90 degrees. So everything should go from this box to this box. Then we're only going 90 degrees, so we're going to flip all of our x's and y's. So that means negative 3, 6 is going to become 6, 3. Negative 6, 4 is going to become 4, 6. And negative 3, 0 is going to become 0, 3. Now notice I don't care about the signs yet because I'm going to have to figure that out later anyway. Now I match the signs. Well, over here my x's are negative and my y's are negative. So all of these are going to become negatives. So this should be negative 6, negative 3, negative 4, negative 6, and 0, negative 3. Then I go ahead and plot these. So negative 6, negative 3. So negative 6, negative 3. 0, negative 3 goes there. And we plot each of these. And notice now I have my triangle that's exactly the same, just spun around. Now, what about 180 degrees counterclockwise? Well, now, again, we write out the coordinates. The coordinates are exactly the same as before. So now we decide which box we're rotating into. So we're going counterclockwise, so here, and it's 180 degrees, so we're moving 2 boxes this time. So 1, 2. So we're over here. For every 90 we flip, so we're going to flip, so the x's become the y's, and the y's become the x's. That moves us into this box. Then when we go back, we end up back where we started, really, right? So our x's are back to being our x's, and our y's are back to being our y's. So we flip, and then we flip them again. And then now we need to match the signs. So over here we have positive x's and negative y's. So we have positive x's, negative y's. And then we plot each of those points, and then draw in our triangle. And notice now it's a perfect rotation. Now 90 degrees clockwise, same thing, write out the coordinates. Decide which box we're rotating into. Well, 90 clockwise is going this direction, so it goes into this box here. And then for every 90, flip them. So 3, 6 becomes 6, 3, and so on. Then we match the signs. Over here, we are positive and positive. So these stay exactly like that. We plot our points, connect the dots, and now we have our triangle that's exactly the same. Let's talk now about how to access your assignments on IXL using SBLink. So what you'll do is you'll click on the link that takes you to your SBLink, which should look like this, and you're going to log in the same way you would log into your computer. So the first part for your username is going to be the first part of your email address without the @sbcusd.ca.us. So it should be your last name, first initial, middle initial, and then the last four of your student ID. Then for your password, it's the same password you use to log into your Chromebook. From there, you'll go ahead and click Sign In. And it should take you to a page that looks kind of like this. You're going to go find the link that says IXL, which is right here. And I'm going to go ahead and click on that link. And it should take me to the IXL login page. So it should look like this. At the top right corner, it should say welcome and then your name. If it does not say your name, then you're not logged in and you won't receive credit for your work. As long as this is good, you can go ahead and close that tab out. And then you can go to your Google Classroom. And then you'll go and find the activity, which is here. And I'm going to click on the IXL link right here. And this will take me to the assignment that I need to complete. So that's how you log into your assignments on IXL using SBLink. Let's take a look now at the Rigid Transformations Part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here that'll take you to SBLink. This will allow you to log in so that you can access your IXL activity. Once you've logged in, return to this page and then click on this link to access your IXL activity. And it should take you to a page that looks like this. It says to graph the image of 0, -2 after a rotation of 180 degrees clockwise about the origin. So here's our point. So a rotation of 180 degrees means we're going to flip our X and Y twice. So now when we go 90, it becomes 2, 0. And then when we do it again, it becomes, again, 0, 2. So it would be this point right there. And then we'll go ahead and click Submit. It tells us we got it right, sends us on to the next one. Now this one says we're going to rotate 3, -6, 90 degrees counterclockwise. So we're here and we're going counterclockwise, which is this direction. So we know we're going to end up in this box here. We're going 90, so we're going to switch the X's and Y's. So 3, 6 becomes 6, 3. So we're going to go 6, 3, plot our point, hit Submit. It tells us we got it right and sends us on to the next one. Notice every time I answer a question correctly, my SMART score goes up. You keep answering questions until you get a SMART score of 80. Once you get a SMART score of 80, you'll go ahead and return to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.